Determine the equation of a line such that its segment between the lines 5x minus y plus 4 equals to 0 and 3x plus 4y minus 4 equals to 0 is bisected at the point 1, 5. Okay, so what we'll first try to understand the problem graphically. So here we have considered three lines. Let's try to go through each of the lines. We are denoting the line 5x minus y plus 4 equals to 0 as L1. We are considering the line 3x plus 4y minus 4 equals to 0. We're denoting it by L2. Then we have the third line L3 and we need to determine the equation of this line. Now L3 is drawn in a very particular fashion. It is drawn in such a way such that, let's say, it intersects the first line L1 at the point A and it intersects the second line L2 at the point B. Now there's also what we get here is the line segment AB. The line segment AB is such that it passes through a point 1, 5, and this particular point 1, 5 is going to bisect the line segment AB. In other words, let's say if it meets AB, passes through the point C with coordinates 1, 5, we can say that AC is going to be equals to CB. So using all of this information, our goal will be to determine the equation of the line L3. So how shall we do that? Now, in order to determine the equation of the line, what we'll do here is we are going to take the help of the distance form of a line. So let the equation of the line be given by, so we know the distance form of a line is given by take the difference of the x coordinate. So if we consider any point lying on this line L3, let's say that line is given by x, y, then we have x minus 1. We take the difference of the x coordinate divided by, now we have to take the cosine of the angle that the line makes with the positive direction of x-axis. So let's say this is the angle alpha that the line L3 makes with the positive direction of x-axis. Then in our case, we have cosine of alpha. This is going to be equals to y minus, so what we need is the difference of the y coordinate. So we have y minus 5 divided by sine of the angle alpha. So let this be the equation of the line. This is going to be the equation of L3, which is what we need to determine. Now, what we'll do here, we are again going to apply the distance formula in terms of the 2 points A and B. So here, let us suppose that let the coordinates of A and B be. So here we have considered the coordinates of the point A to be x1, y1 and the coordinates of point B to be x2, y2. Okay, now again what we can do, we can apply the distance form. So let's consider the point A, considering the point A and the point C. But when we apply the distance formula, so what we need is the difference of the x coordinate. So we'll do x1 minus 1 divided by, now this is going to be the same angle that the line makes because the line is making an angle alpha with the x-axis. So we take cosine of alpha equals to the difference of the y coordinate. So we have y1 minus 5 divided by sine of angle alpha, and this is going to be equals to the distance AC. That means distance between the 2 points. Now in the given, it is already given that AB is bisected by the point C. In other words, we have AC equals to CB. So here, this is going to be equals to R, where we are assuming that AC equals to CB. Let's say this equals to R. So we're representing it by the letter R. Now what we have here is x1 minus 1 divided by cosine of angle alpha. That is going to be equals to R. And then we could also have y1 minus 5 over sine of the angle alpha. That is going to be equals to R as well. So x1 becomes equivalent to 1 added to R cosine of alpha. And then y1 becomes equals to 5 plus R sine alpha. So what we have done here is we have now converted the coordinates of point A, which we initially considered to be x1, y1. Now we have converted into its corresponding parametric form. So the x1, which is the x coordinate, is going to get replaced with 1 plus r cosine of angle alpha, and the y coordinate will be 5 plus r sine of the angle alpha. Right? So this is going to be the coordinates of point A. Let's keep that aside for the time being. Next, what we'll do, we're going to find out in the similar fashion the coordinates of point B, represented in the parametric form. So again, we apply the distance form. So this time we have 1 minus x2. We are taking 1 minus x2 because the point B lies to the right of the point C. So we have 1 minus x2 divided by cosine of the angle alpha, that is going to be equals to the difference of the y coordinates. So we have 5 minus y2 divided by sine of the angle alpha, and this is going to be equals to the length BC, which we have considered to be equals to r. So in other words, we have 1 minus x2 divided by cosine of angle alpha, that becomes equals to r, and then we have 5 minus y2 divided by sine of angle alpha, so that is also equals to r. So this times x2 becomes equivalent to 1 minus r cosine of angle alpha, and y2 corresponds to 5 minus r sine of angle alpha. So this time what we have done, we have now successfully converted the coordinates of the point B, which we initially considered to be x2 comma y2. We have converted into its parametric form as 1 minus r times cosine of angle alpha, and the y coordinate is 5 minus r times sine of angle alpha. Now that we have the parametric coordinates of A and B, okay, here we can say that since the point A, this particular point A lie on the line, it's going to lie on the line L1. So clearly the L1 whose equation is already given to us, it has to satisfy the equation of the line. So in other words, what we have 5x plus y minus y plus 4 equals to 0, but in place of x we can replace it with the x coordinate of point A. So that is 1 plus r times cosine of angle alpha minus y. So y will get replaced with 5 plus r sine alpha, and then this is going to get added to 4, and this is going to be equals to 0. So we have 5 added to 5r cosine of angle alpha minus 5 minus r sine of angle alpha plus 4 equals to 0. So what we have is we can cancel out 5 and 5 from both sides. Now taking r as the common factor, we have 5 times cosine of angle alpha minus sine of angle alpha. This is going to be equals to negative 4. Solving for r, we get r equals to negative 4 divided to 5 times cosine of angle alpha minus sine of angle alpha. Okay, so let's skip this aside for the time being. Also, we can say that the point B, this is going to lie on the line L2 with the equation 3x plus 4y minus 4 equals to 0, which means that there's two coordinate values of x and y of B must satisfy the equation of line L2. So our equation of the line is going to become 3 times x. So in place of x, we have 1 minus r cosine of angle alpha. Then we have plus 4y, so we have 4 times y, so y will be 5 minus r sine of angle alpha minus 4, that's equals to 0. So let's simplify this equation to obtain the value of r. So we get 3 minus 3 times r times cosine of angle alpha plus 20 minus 4 times r times sine of angle alpha minus 4 equals to 0. So we have now, so we can take r as the common factor. So if we take negative r as the common factor, so we are going to get 3 times cosine of angle alpha added to 4 times sine of angle alpha. This is going to be equals to, now we have 20 plus 3, so that's 23. 23 minus 4, that's going to give us positive 19. We're going to transpose it to the right hand side to get negative 19. So we now have the value of r. So r comes out to be equals to positive 90 divided by 3 times cosine of angle alpha plus 4 times sine of angle alpha. Okay, fine. Now what we got? From the previous equation, we got r value is negative 4 over 5 cosine alpha minus sine alpha. And this time we got r equals to 19 over 3 cosine alpha plus 4 sine alpha. But we know that these are the same r values. So what we can do? We can equate them. Fine. So what we'll do, we're going to cross multiply them, and that's going to give us, so 19 times 5, that's going to be 95 cosine of alpha minus 19 sine of alpha. This is going to be equals to negative 12 cosine of angle alpha minus 16 sine of angle alpha, which is going to be equals to, so we have 107 cosine of angle alpha. That is going to be equals to 3 times sine of angle alpha. So what we have now is, if we take sine alpha over cosine of angle alpha, that comes out to be equals to 107 divided by 3. Okay, so this is nothing but the ratio of sine to cosine, that is the tangent function. So we have tangent of alpha equals to 107 over 3. Okay, we are almost there. Finally, what we'll do, we'll go back to our original equation where we obtain that x minus 1 over cosine alpha equals to y minus 5 over sine alpha. This is the equation of L3 that we considered. So let's come back to that. So equation of L3, this is what we need to find. So we obtain x minus 1 over cosine of angle alpha, that's equals to y minus 5 over sine of angle alpha. In other words, what we can do here is we can rewrite this equation as y minus 5 equals to sine alpha over cosine of angle alpha whole multiplied to x minus 1. So sine alpha over cosine alpha, that's nothing but this tangent of alpha value, the y minus 5, that comes to be equals to 107 over 3 whole multiplied to x minus 1. So let's further simplify. We're going to multiply throughout by 3 to get 3y minus 15. That is going to be equals to 107x minus 107. So we get 107x minus 3y. This is going to be equals to 92. So this is the required equation of L3. So we have finally obtained the equation.